Okay, so the last thing I'm going to do quickly is show you the IsoVist function within Grasshopper, and this is a quick way to figure out view vectors within your model. And this might be useful if you're doing some analysis about what can be seen from different points on your site or where your site can be seen from in your context. Okay, so what we're going to do now is basically use the IsoVist function. IsoVist is under the intersections tab in Grasshopper, and under mathematical you see these two options down here, IsoVist and IsoVist Ray. And IsoVist is it's fundamentally like an intersection tool, but it automates a bunch of processes for basically calculating view vectors. So it wraps together all the functions to specify a point, figure out the intersections of a line from that point to a series of vectors in a 360-degree radius. It'll calculate all the intersections to all the objects in the scene, and it'll give you back those intersection values. So it basically automates things you could do manually within Grasshopper, but it's really useful for figuring out the views from a certain point. So I'm going to create one of these IsoVist nodes, and then I'm going to reference some pieces of geometry, and here I brought in just the site that you guys are working with. So IsoVist will take in a series of parameters. Here we have a plane, so this is the plane at which the vectors or the views will be calculated. And we want to set this to something like an eye-level plane. And the number of vectors coming from that point, and then the radius at which it's going to try to sample those vectors. Okay, so I'll just go step by step and show you how this works. I'm going to create a pipeline. So we did this in the first week. I'm going to use this pipeline to bring in all my building geometries. So I could create a geometry node and manually select all these buildings, but it's much faster to just use a pipeline to automatically bring those in from our model. So in the pipeline, we specify the layer. All the buildings are in the buildings layer. And then the type of geometry, we're going to specify these surfaces. And you can see now it's brought in all of our buildings all at once. The next thing I'm going to do is specify a point, which will create the point from which the vectors will originate, and also the level at which the analysis will be done, which is something like eye level. So I'm going to just create a point in my model here. And I'm also going to move it vertically some distance up. It doesn't have to be super exact, but you want it up at above the ground level. Okay, I'm going to create a geometry node to bring that point into our Grasshopper model. So here's that point. I'm going to use this point to basically to create a plane. So I'm going to create a XY plane here. This is the basic XY plane. By default, it's going to start at the origin, so it's going to be at the ground level of our model. But it also has this origin input where we can import a point, and now our plane will be basically originating at that point, but be in the XY direction, which is what we want. And then we're going to import this plane, input it into the plane input. And again, this will designate the point from which all the vectors will originate, and also the plane which will be used to generate the vectors. All right, so for count, we'll just start at 10 to default, and then we can increase this number, basically increase the resolution of our analysis. For the radius, we're going to keep the default, but we can also change this depending on the size of our model, how big of a radius around the point is going to calculate those intersections. And then for the obstacles, we're going to put in all of our building geometry. Because IsoVist is a two-dimensional tool, it's not going to accept surface geometry for its calculations. It really needs a set of boundary curves to calculate those intersections. This is really easy to do though, because we already have this plane. We're basically going to use this mathematical intersection tool to calculate the intersections between the plane that we have, the XY plane, and all of our buildings. So we're going to create this BREP plane intersection. For the BREP, the surfaces, we're going to input from our pipeline. And then for the plane, we're going to put in our XY plane. Now if we hide these, you can see that it's calculated all the intersections with our buildings, and it's done this at the level of that plane. Okay, so now we have, these are going to be our obstacles. Alright, so we have a result. I'm just going to hide a few of these other pieces so we can see what's going on. You can see it's not exactly what we want. It's generating a lot of these intersections with things that seem to be not in the line of sight. That's because it's brought in our geometry in this kind of tree organization. So we just want to flatten all of those curves so they're all considered as one object. And now what IsoVist has done is it's basically projected 10 lines from this point, and it's figure out the first intersection of each of those obstacles. So if we imagine all of those 10 curves as view lines, it's going to tell us where our view terminates. So those are all those green points are all the first intersections. And at moments where there is no intersection, you see it ends at this ring, and that's specified by our radius. So we can start to set parameters for each of these inputs. For a radius, maybe we'll do something bigger. So you can see how this changes. And you want to set this to something that makes sense for your model. You can also set a parameter for the number of view vectors. So I'll create a slider that ends at 100. I'll set this down to the default 10 vectors. Plug this in here. And as we increase this, you can see that we just increase the resolution of our analysis. Just like with anything else, the more resolution, the better the results, but also the slower it's going to take. Since this is a pretty simple analysis, it's not that big of a deal. Okay, so now when we have all of those intersections, we can interconnect them. Right now they're just points in the list. So we can use the polyline node and feed in all those points as vertices. It's going to create a polyline. Here we can tell it to close it at the end, so it's going to connect the last point with the first point. We'll hide that, and now we have basically a polyline representing what we can see from that view. And then we can feed that polyline into a boundary surface node to get the actual view. You see there's something weird happening because these buildings are actually elevated somewhat. It's not capturing those in the intersection. So what you can do is just flatten everything to the ground plane. Or you can just change the height of this point. So you can elevate this point a little bit, and now it's calculating the intersection of all the buildings. So basically, you can play with this resolution, and at some point, now from any point in the model, it's going to tell us what we can see around the site. So now as we move this point around our model, we can start to get a sense of the views either from the site towards or from the context towards our site, or from our site towards the context.